Dear students, Ambition Classes provides the easiest way to learn. Today, we are going to discuss light, reflection, and refraction. This is chapter 10, and this is the first video in the series of light, reflection, and refraction. What is light? Light is a form of energy, and reflection is one of the unique properties of light. It is a reflection of light which enables us to see any object. So when the light falls on an object and the light is reflected back by the object, then only we can see the object. The light wave is an electromagnetic wave that does not require any medium for its propagation. Electromagnetic wave means it creates electric field and magnetic field when it propagates. Velocity of light in a vacuum is 3 into 10 to the power 8 meter per second. The direction or path along which light energy travels in a medium is called ray of light. So we can say path of light is known as ray of light. A group of light rays is called a beam of light. Reflection of light occurs when light falls on a highly polished surface. So when the light falls on a highly polished surface, it is reflected back. Reflection of light occurs when light falls on a transparent medium. It means when light goes from one medium to other medium, then refraction occurs. We'll discuss in detail about reflection and refraction. When a beam of rays starting from a point source of light suffers a change in direction due to reflection or refraction, and the reflected or refracted rays actually meet or appear to meet at second point, then the second point is called the image of the first point. Try to understand when a beam of rays coming first point meet or appear to meet after reflection or refraction at second point, then the second point is the image of the first point. Reflection, the bouncing back of rays of light from a surface of an object when the light incident on it is called reflection or refraction of light. It is similar to bouncing back of football after colliding with a wall or any hard surface. There are two laws of refraction of light. The angle of incidence is equal to the angle of reflection. The incident ray, the reflected ray, and the normal to the surface at the point of incidence all lie in the same plane. We'll try to understand from this figure. This is the incoming ray. This is incident ray which strikes a smooth surface. Suppose this is mirror, and this ray is reflected by along this path. So this is incident ray, this is reflected ray, and this is the normal to the surface at the point of incidence. Then this angle is known as angle of incidence, that is angle between normal and incident ray, and the angle between reflected ray and normal is known as angle of reflection. So again I repeat, the angle between incident ray and normal is known as angle of incidence, and the angle between reflected ray and normal is known as angle of reflection. According to laws of reflection, this angle of incidence is equal to angle of reflection. If this is 30 degree, this will be 30 degree. Now, incident ray, reflected ray, and normal all lie in the same plane, that is in the plane of the paper. So we say they lie in the same plane. Now, this law of reflection is applicable to all types of reflecting surface. Regular reflection. When a parallel beam of light falls on a smooth or highly polished surface, remain parallel after reflection, then the reflection is known as regular reflection. So here we can see this is the mirror. You can see, okay, suppose this is the plane mirror and these are the incident rays. They are parallel and they strike this surface and they go to this direction, and these are parallel incident rays and these are parallel reflected rays. So parallel incident rays remain parallel after reflection. So this is regular reflection. Irregular reflection. When a parallel beam of light falls on a rough surface, do not remain parallel after reflection, then the reflection is known as irregular or diffuse reflection. Example, reflection from table, book. Okay, here we can see the surface of the table looks like this when we see the surface of the table with microscope. So when these parallel rays strike the surface, they will diffuse after reflection. They do not remain parallel. So this type of reflection is known as diffused reflection. Now, there are two types of image formed by mirror, real and virtual. Real image which is formed in front of the mirror and it can be obtained on a screen is called real image. It is formed due to the real intersection of rays. That means when the rays coming from an object intersect each other after reflection, then the image form is known as real image, and this is formed in front of the mirror. Virtual image which is formed behind the mirror and cannot be obtained on a screen is called virtual image. Here the rays do not intersect each other but appear to intersect. Now we are going to discuss image formed by plane mirror, and first we should know about plane and spherical mirror. Types of mirror, plane and spherical. Plane mirror, a mirror having a flat surface is called plane mirror. Okay, now how image is formed in a plane mirror? A plane mirror always form virtual and erect image. Here you can see this is the object. Rays are coming from this object and they are reflected back in this direction, and when they extend behind the mirror, they appear to come from point A prime. So A prime is the image of A because these rays appear to come from A prime. Okay, so the image of A is A prime. The distance of image and that of object is equal from the mirror. The image formed by a plane mirror is laterally inverted. It means the distance object A from the mirror is equal to the distance of the image from the mirror. So both the distance of A from the mirror and distance of image, it means A prime from the mirror, same. Okay, and the image is laterally inverted, left becomes right and right becomes left. A spherical mirror having curved reflecting surface are called spherical mirrors. A spherical mirror is a part of a sphere. A spherical mirror can be divided as concave and convex. Concave mirror, when the reflecting surface curved inward, is called concave mirror. Convex mirror, when the reflecting surface, okay, curved outward, is called convex mirror. Here, this is the reflecting surface. This reflecting surface is bulked inward, and here this is the reflecting surface and this is bulb outward. So this is concave mirror, we can remember as cave, and this is convex mirror, opposite of concave. Few things we should know about these spherical mirrors. Okay, this is the mirror. So mirror is a part of a sphere. So center of the sphere from which the mirror is formed is known as center of curvature. Midpoint of the mirror is known as pole, and the line passing through center of curvature and pole is known as principal axis. The distance between pole and center of curvature is known as radius of curvature. And all the rays which are parallel to the principal axis meet at a point at F after reflection. So this is the focus. This is known as focus. These are for concave mirrors. Same in the case of convex mirror, this is also part of a sphere and center is behind the mirror. This is a reflecting surface. Okay, we always keep reflecting surface towards the left. So, okay, the center of the sphere from which mirror is formed is known as center of curvature, and the rays, and this is the pole, and PC is the line which is known as principal axis. All the rays parallel to the principal axis appear to come from focus, that we will discuss later. This is the pole. Distance between P and C is known as radius of curvature. Distance between P and F is known as focal length. So, as we have discussed, the center of reflecting surface of a spherical mirror is known as pole. Pole lies on the surface of a spherical mirror. Pole is generally represented by P. Center of curvature, the center of a sphere of which the reflecting surface of a spherical mirror is a part is called the center of curvature of the spherical mirror. Center of curvature is not a part of a spherical mirror, rather it lies outside the mirror. Center of curvature is denoted by C. In the case of concave mirror, as we have seen, center of curvature lies in front of the reflecting surface. And in the case of convex mirror, the center of curvature lies behind the reflecting surface. Let us try to understand. So this is the center of curvature in front of the mirror. This is center of curvature behind the mirror. Here, this is the reflecting surface. Here, this is the reflecting surface. Okay, so now radius of curvature, the radius of a sphere of which the reflecting surface of a spherical mirror is a part is called the radius of curvature of the spherical mirror. The radius of curvature of a spherical mirror is denoted by R. Radius of curvature lies in front of the concave mirror and lies behind the convex mirror and is not a part of the mirror as it lies outside the mirror. Today, we are going to end the topic at this point only. In the next video, we will discuss more, which are very, very important, and it is very essential to know. So, let us end the topic, and very soon, you will get a second video which includes rest of the topics which are remaining.